Welcome everyone to the Intel Network Builders webinar program. This is Bree Hilliard, Intel Network Builders webinar program manager and your host for today. Thank you for taking the time to join us for our presentation titled Hardware versus Software BNGs, Gaining Competitive Edge for a 5G Future. Before we get started, I want to point out some of the features of the BrightTalk tool that may improve your experience. There is a questions tab below your viewer. I encourage our live audience to please ask questions at any time. Our presenters will hold answering them until the end of the presentation. Below your viewing screen, you will also find an Attachments tab with additional documentation and reference materials which pertain to this presentation. Finally, at the end of the presentation, please take the time to provide feedback using the Rating tab. We value your thoughts and will use the information to improve our future webinars. Intel Network Builders webinar series takes place live every week, so check the channel to see what's upcoming and access our growing library of recorded content. In addition to the resources you see here, we also offer a comprehensive NFV and 5G training program through Intel Network Builders University. You can find a link to the university program in the Attachments tab as well. Today, we are pleased to welcome Michael McFarland, VP of Product Management at Benu Networks, and Paul Mannion, SDN-NFV Market Segment Director at Intel. Mike is responsible for product management and marketing at Benu Networks. He has over 20 years of networking and telecom experience. He's taken startups to global market share leadership and led billion-dollar product lines. Prior roles include head of product for CommScope's 3G and 4G wireless small cell business unit, acquired from Airvana IPO in 2007. Mike was also a senior product manager at Cisco Systems for several multi-billion-dollar product lines, a founder of SetWave, and has strategy and technology roles at Mercer Management Consulting, Ameritech, and Accenture. Mike holds an MBA from J.L. Kellogg School of Management and a BSME from Northwestern University. Paul Mannion has worked in the telecommunications industry for 25 years. He has a variety of engineering and product management roles, mainly focused on high-speed packet processing technologies. More recently, he's been focused on edge network transformation due to SDN-NFV, with a particular focus on wireline edge and fixed mobile convergence. Paul holds a bachelor in electronic engineering from the University of Limerick and an MBA from University College Dublin. Welcome, Mike and Paul, and thank you for taking the time to join us today. Mike, I'll hand it over to you to start off.
Thanks, Bree. So I want to start off with just a brief introduction of Benu Networks. So we are deployed at scale across a variety of carrier networks, both big and small, around the globe, and have been deployed for roughly 9 years in some of these networks. And at this point, we are carrying a tremendous amount of traffic, about 7 petabytes a day. That's more traffic than all the North American wireless operators combined. And we've got tens of millions of subscribers and gateways connecting through our platforms. We're headquartered in Boston, and we're very much focused on the edge of carrier networks and heavily engineering driven. We've really prided ourselves in our innovation, and of course, the vast majority of our engineers, the vast majority of our employees are engineers. Paul, I'm going to give it back to you to introduce Intel's work in this area.
Sure. Thanks, Mike. Yeah, so Intel, we've been involved in 5G transition for 12 to 15 years now. Lots of folks, I guess, associate Intel with the PC and the data center. But I think the best way to introduce our work in the telecommunications industry is just to talk you through this slide here, where you see the typical, I guess, from core to wireless access topology that you would see in a normal operator. So Intel, I guess we've been prevalent in the core of the network for a good 10 years now. There's been 30 million Xeon processors sold into that part of the network, doing things like the EPC, the IMS, the OSS and BSS back office stuff. Also, since the advent of NFV, we've been out on the right of the network here, working in areas such as the remote unit for CRAN, the distributed unit and the centralized unit. So a lot of RAN transformation technology, and that was one of the main places where we positioned our EASIC acquisition to do some of the 5G offload technologies. So that's all there. That's been there for the last 5 to 6 years, I guess. We're working on the most recent emanation of that is the ORAN project. But what we're noticing in the last 2 years is this area here, this interesting area in here in the middle called the central office or the near edge. Lots and lots of activity here. You know, a realization of the operators that they have huge advantages here with fiber, so that the BNG is transforming. Lots of services and willingness to put services into this location to get the advantage of the bandwidth and the latency. And we're also seeing migration of the mobile core technologies out of this part of the network. And that's the focus of the talk today, and the technologies that we'll be presenting with you at Benu is on this part of the network here, the central office or the near edge. Okay, back over to you, Mike.
Thanks, Paul. So today's topic is to go over the broadband network gateway and the opportunity there. So the broadband network gateway, or BNG, can be implemented using proprietary hardware. It can be used implemented with software running on off-the-shelf hardware, like on Intel servers, or you could have a mix. And for any one of those implementations, there understandably are trade-offs, just as if you were trying to choose a car to purchase, whether it be, in this case, I'm showing a Cadillac, a Tesla, and BMW. These are all, fully functional cars. They'll get you to where you need to go, but there are trade-offs between them, right? And so one of the things we're going to do in this presentation is talk about what are some of the user needs that people have, and specifically how those needs are creating key trends that are impacting the BNG market. And then with that context, we will then discuss, okay, what are some of the trade-offs of a hardware versus software BNG, and how do they deliver on, meeting those requirements changes, meeting those or reacting to those trends in an effective way. And what's the opportunity there then for carriers? And then finally, we'll wrap it up with a Q&A, but as Bree mentioned, you're welcome to ask questions along the way if they come up. We'll actually answer them at the end. So with that outline, let's jump into it. So just to level set, I think most people that probably are attending this know what a BNG is. The topic was very focused on this, but the BNG is the gateway that is really probably in the most strategic part of a carrier network. It's between the access network and the core and transport network. And it's aggregating all that traffic from homes and businesses coming over DSL and PON connections. It really acts as the service edge for those homes and businesses, and it's typically managing the home and business at the home business level, but and so you would implement policies for the entire home and the entire business. But Benu does, and we'll talk about this in a little more detail later, does have an option to support per end user device policies, which gives you a little more, obviously, actually a lot more granularity, since there's, within any given home, there could be 20, 25 devices at this point, these days. And then businesses, of course, have many different types of users and devices. So that's where the BNG sits, a very strategic aspect and important part of a carrier infrastructure, and has a big impact on the services and capabilities that the end consumers have access to. So what are some of the key changes and requirements from an end user perspective? Well, one is there's a lot of interest from end users to take advantage of 5G and the evolution there. Obviously, with the pandemic, everyone, or not everyone, but a lot of people are working from home. And so teleworking has become a huge trend. And what's interesting is it seems to be a long-term trend as the businesses look at the fact that a lot of their employee base has been perfectly productive, maybe even more productive in a teleworking environment. It raises the question of whether they need to be spending all that money, tens of thousands of dollars per employee on real estate cost for office space. And so should they be simply enabling those people working from home with a really high quality teleworking experience for far less money. The other aspect that's happening is IoT, both within homes and businesses. There's a lot more connected devices. There's also a bigger and bigger reliance on cloud. I mean, if your internet connectivity goes down, there's so many things you no longer can do. And so cloud reliance has become really important. And so the reliable connections is critical. And then, over-the-top service adoption is also, very popular now. There's a lot of streaming services, and those are starting to replace traditional television services. And there's, all kinds of music services and things like that also run over the top. So how does that impact what your BNG, if you're a communication service provider or internet service provider, what does your BNG now need to do differently? Well, for one thing, it's got to be supporting higher bandwidth because you just have so much more traffic going over to the network, and it's growing quickly, 30-40% year over year. You also need to have the flexibility of a software-defined service edge. So, like I mentioned before, you might still use hardware in your architecture, but you want those flows to be defined via software-defined networking. Another aspect is support for network slicing. So you want to be able to create a different slice for example, a Teleworker or an IoT device, because they're going to need different types of bandwidth priority, different types of security levels, different levels of analytics, things like that. And the fourth element there is providing value-added services on top of the broadband connection. Part of that is to reduce churn with your consumer base, who, if they've disconnected their landline, they've disconnected their television, it's now just a broadband connection. It's fairly easy for them to switch. But if you start to layer on services, then you're going to get more loyalty from your end customer, and you're going to provide more value to them and perhaps drive some more revenue. And then the last thing is there really is a lot of interest around fixed mobile convergence, such that you can have a consistent user experience. And so I think being able to deliver on that via the BNG is gaining more and more important. So with that, I want to hand it back over to Paul to talk a little bit about how the central office itself is transforming.
Thanks, Mike. Yeah, so as Mike just mentioned, the BNG is deployed in this location, the central office. It's already a hugely strategic location for operators and for service providers because of that ability to provide that high bandwidth, fiber-enabled access to these edge services, which Benu can deliver as part of their offering. And that is part of the problem here. This opportunity doesn't come without the realization that, operators realize their legacy services, voice, the IPTV, data services are, they're diminishing year on year. More competition means that your ARPU is dropping. So you have to come up with more ways and different ways, like Mike described on the previous slide, more services, more value added, residential and enterprise services, and you have to quickly deploy them in this location, and some will fail and some will succeed. So we have to lower the cost of experimentation in this part of the network through software and through software services. The third part of this is the whole cloud native approach. So we've seen what the hyperscalers are doing. They're moving towards the edge of the network. They bring that huge scale with them, that huge ability to automate at scale, to introduce services at scale and to remove them at scale. But this also offers opportunity for the service provider, the communications service provider, and the supply chain to the communication service provider, because this infrastructure that we talk about, this cloud native infrastructure, is ideal for enabling that convergence, that network convergence that Mike will get into in more detail later, that fixed mobile convergence, while also providing that bed of infrastructure onto which you can also deploy these services. So that's why this location is important. A lot of transformation and a lot of opportunity here, but it doesn't come without its challenges. Okay, Mike, back to you.
Yeah, thanks, Paul. So some key trends that are opening opportunities for carriers. So one of them is wired and wireless used to be very separate services. More recently, though, you see some of the operators that have both wired and wireless assets provide single billing for both. But now I think there's really an opportunity to drive true wired and wireless convergence. And just as an example of some of the value this could be provided, I certainly would be interested in this because as a dad who's got kids, setting up parental controls for devices that connect over our Wi-Fi network versus the devices that connect over a wireless, 4G network, it's a totally different setup. It's a whole bunch of work to do both, and it's really it's not an easy experience. Whereas if the operator could say, hey, I can set up a parental control solution that works across both seamlessly, you set it up once, the same policies implemented, no matter how your son or daughter is connecting to the internet, that would be of great value to me. I would pay extra for that. Another big trend is the fact that in the past you had relatively few users and devices, but now there's a proliferation of users, devices, and applications all using cloud services. And we'll get into that in a little more detail as well. And then consumer broadband, like I mentioned before about teleworkers, is really transforming consumer broadband. So it's no longer about a basic connection to the home. There's an opportunity here for carriers to add on an enterprise teleworker slice, if you will, that could add significant revenue. And so I think, there's tens of billions of dollars of opportunity here for carriers. So let's dive into each one of these in a little more detail. So the first trend, which is the 5G wired and wireless convergence, and I specifically call out 5G because the standards here are taking what I would say is a much more earnest approach to creating a true wired and wireless convergence. So about with the current projections from analysts, a few years out from now, there will be about 20% of the traffic, internet traffic, will go over wireless networks like 5G, 4G, 3G networks. And if you want to have convergence and address the fact that 80% of the traffic goes over the fixed network, you need to evolve your BNG into a new element that's called the 5G Access Gateway Function, or AGF, and that usually also incorporates a user plane function. And that function is being defined in a joint effort between both 3GPP, which handles all the wireless technologies, and the Broadband Forum, which handles a lot of the wireline technologies. And so it's a very good collaboration, and it's enabling essentially the ability to apply 5G capabilities to your fixed and Wi-Fi network. So if you want to have, network slicing, low latency compute access, high speeds, things like that, the 5G AGF is really your vehicle to delivering 5G capabilities to your fixed network and Wi-Fi networks. And the nice thing also is there's the option here to manage each device, not just the residential gateway or RG, but each device individually, such that you have that consistent user experience across both fixed and mobile. So I used the parental controls as an example there, but there's numerous things that could apply there, like a teleworker. Maybe an enterprise wants the teleworker traffic on fixed and mobile to go through the exact same levels of security inspection. Then that is perfectly capable and possible with a wired wireless convergence, and is something of great value to the customer. The other big trend is the proliferation of users, devices, and applications. So, in the past, it was really the adults in a household that were connecting to the internet, but now you've got the teens, the kids, even pets that might have a connected collar. So you have more users that are involved. You've got far more devices. Traditionally it was just some computers in the home or business. Now you've got all the mobile devices, tablets, mobile phones, but even watches, Fitbits. You've got all the streaming devices, like the streaming sticks. You've got the gaming consoles. You've got a lot of IoT devices now popping up everywhere, whether it be smart speakers or thermostats, smoke detectors, even door locks. And then, of course, there's next-gen types of devices that do virtual reality, augmented reality, those kind of things. You also have a variety of different applications that have different needs. So you have high bandwidth applications that also require low latency, like some of the gaming or VR and AR. The high bandwidth applications that not so latency sensitive, but very high bandwidth, like 4K streaming. And then you've got also applications that are low bandwidth, but have lots of connections, lots of intermittent connectivity that's required. IoT devices like would be an example of that. And then your traditional bursty traffic, which is internet browsing and downloading various applications, games, things like that. And then, of course, user needs are changing too. So they continuously want higher bandwidth connectivity so that everything works faster, better security. This has been a terrible year for hacking. There's been a huge increase in hacks. I think driven a lot by the fact that a lot of people now are no longer sitting behind a enterprise class firewall when they're at work. They're now just behind a regular residential gateway. And so the security aspect of a employee working from home, there's just much less security there. The cybersecurity is really been battling that. And so there's a need here for carriers to help enterprises with enterprise class security, but without having to deploy a Palo Alto firewall or Fortinet or Cisco, whoever your firewall vendor is, not have to deploy that at every single home, right? So, so what is the solution here? So you want to be able to provide scalability on your access network, and particularly through your BNG. You need to support software-defined LAN, not just software-defined WAN, but software-defined LAN and network slicing, so you can optimize different users, devices, and applications, both in the businesses and in the homes. And then lastly, with all the over-the-top applications, content distribution networks need to be pushed further out to the edge so that you're not trying to run 4K streams across your entire network. And you need to also have low latency compute closer out to the edge. And so this is a key component, is being able to move the BNG out to the edge to support these services closer to the end user. So the third trend, which I alluded to, is the teleworker trend. And, some interesting research here. One of the surveys that was done quite broadly surveyed a variety of employees, and they said 48% of them were less likely to follow safe data practices when working from home, which obviously is a huge security threat. And I think that's because they're feeling like, hey, we're at home, don't have sort of the same level of scrutiny perhaps that you would have when you're in your business office. And then the other thing is, a third of the remote workers admitted they would spend money to help them work remotely during COVID-19. So there's actually a huge amount of demand to improve telework connectivity. So again, this is a big opportunity for carriers to provide a network slice that is a teleworker service and really deliver enterprise capabilities from the network. And you can do this in leveraging the carrier's infrastructure, layering services onto the BNG versus having to deploy a whole new set of residential CP equipment. If you do some back of the napkin calculations here, say you get an extra $20 per month on these consumer broadband connections, and you've got like a 30% attach rate. For a large operator, that might be 5 million subscribers. That's a $1.2 billion increase in revenue each year. And for smaller operators, it might just be 50,000 subs, but still $12 million extra for a small operator. These are really significant numbers. These are the kind of numbers that Wall Street pays attention to, and certainly the CEO of any carrier would pay attention to. So let's dive into sort of how you might implement a BNG, and then we'll talk about the trade-offs of these different approaches in the context of some of those trends and requirements that we're seeing in the market. So the first and more traditional way to implement a BNG is with legacy proprietary hardware platforms. And so you have your control plane, your data plane, your switching for switch ports, because you need switch ports to aggregate all the DSL and PON OLT connections. So those are all integrated into basically one big box. Another approach is to use more of a software-based approach. And so you're running software on off-the-shelf servers. And on the left-hand side here, I'm showing an architecture that's using a CUPS-based architecture, so control plane and user plane separation. That's what CUPS stands for. The control and user plane are separated. So you have the BNG control plane on one or multiple servers, whereas the data plane is running on a separate set of servers. They could be in different locations in your network. So the control plane might be more centralized, whereas the data plane components are further out to the edge, closer to the subscribers. And then you probably need some switching infrastructure just for port density to aggregate all the DSLAMs or OLTs. Another approach with software is still a disaggregated approach, where you're using software that runs on top of off-the-shelf hardware, but you integrate the control plane and data plane onto the same servers. And then of course you need your switching infrastructure for some port density. And then another, of course, third option here, I should say fourth option, is a hybrid option where you have the BNG control plane, again, disaggregated, running as software on an off-the-shelf server, and still using CUPS, where you've got the control and user plane separated. But here you've integrated the BNG data plane into a switch, and so probably have a fairly tight dependency there between the software and the hardware. It wouldn't be like a true disaggregation, so I called this a partial disaggregation, because the control plane is still has hardware and software disaggregation. But here it's you're taking advantage of the switching infrastructure to run the BNG data plane. So these are really the four kind of different, at a high level, three options with four different architectures. And there's definitely trade-offs between these. So why don't we jump into that? And what we did is we evaluated these between a couple different parameters. So as you saw when we talked about the trends and the new requirements coming out, bandwidth scaling was a key one, because there's so many more users and devices and applications, and there's also some of those applications drive a lot of bandwidth. So this is a critical aspect to consider. And when you look at this particular aspect, a hybrid solution is particularly effective. The hardware-only solution requires you to scale both control plane and user plane kind of at the same rate. Whereas with bandwidth scaling, you really want to be able to scale the data plane, the user plane, separately, because the control plane doesn't need to scale as much. And so hybrid is really optimized for this and does provide a cost advantage. And software is the one that I think has probably the biggest challenge. But it's interestingly enough, as we ran some numbers and compared, given some of the improvements in performance on Intel chipsets, and we're going to talk about that later, about some dramatic improvements. The software is not that far off. So hybrid solutions probably have about a 20 cents per subscriber advantage, which is not particularly significant, but it is there. The other aspect is space and power consumption. So it's another element of cost kind of related to bandwidth scaling. And so similar results here where the hybrid is just simply stronger. The third element we looked at was scaling control plane and user plane separately. And this is where you'd need the CUPS architecture to really effectively do that. And so in the sort of hardware only proprietary approach, you really can't do that. But with software and hybrid solutions, you definitely can, and that's probably going to be the primary way most of those BNGs are deployed. In terms of slicing in sort of edge services, this is where software really stands out, because once you are treating packets with a more software-based solution, you can kind of do anything with those packets. So you can add more services. And it's also, you've got more flexibility in terms of kind of the size and scale of your BNG, and particularly your user plane. And so you can push it out to the edge very flexibly without a lot of extra cost. And the fact of the matter is here, if you're adding in services, you could probably get an extra $5 per month more from a bunch of your subscribers. And so that is a very big business advantage and commercial advantage for the software-only approach. Hybrid can do some of this, particularly if you have some of the traffic going to a software-based user plane that has the additional packet processing capabilities, can really look deep inside the packet, provide additional security, or do application-aware prioritization, or device-aware prioritization, things like that. Similar results for Teleworker, because it's very much, again, layering on a service. And like I mentioned before, this could be very significant revenue for a carrier, perhaps an extra, $20 or so per month. And software really stands out here. Hybrid, again, could do some of this. The legacy hardware approach, you're really limited to what the ASIC in that hardware can do. And so you'd be very constrained in terms of what kind of advanced services. You certainly wouldn't be able to provide really full-blown enterprise class security services without having to sort of send packets off to another security device and sort of touch them twice. And then the last aspect we looked at was just availability in the market. So the challenge with the hybrid solution is it's still not really to market yet. There's definitely some trials going on, and but it's not commercially available or commercially deployed yet. I would say that Benu is really focused on these latter two, the software and hybrid approaches. We're working with some switch partners, but we also have our software-only solution. So that kind of lays out some of the pros and cons. Obviously, if you're really just focusing on cost and not really concerned about services at all, you might take a different approach than the software approach. Whereas if you're thinking about how do I layer on services, you're probably going to look more closely at the software approach. I'm going to hand this back over to Paul to talk a little bit about some of the technology that Intel is providing, which has been fabulous. We've been working very closely together with Intel, and it's been a very good collaboration and partnership. So, Paul?
Thanks, Mike. Yeah, so as Mike showed on the previous slide and mentioned, not every server is the same. And one of the things that we noted, I guess 4 to 5 years ago when NFV started, was that you need a different configuration in your server for high-speed packet processing. And that led us to develop this. It's a blueprint. It's a reference architecture. It's called the Intel Select Solution Forwarding Platform. And this platform has a different PCI configuration, and it has a different I/O configuration. It's still standard parts. There's nothing special, but we have built it and configured it especially for high-speed packet processing. So on something like today, a Cascade Lake server of a two-socket server like you're watching here, like you're looking at here, you could get 200 gigs to each CPU. That would be, a 400 gig capable platform. That's not to say you'll get 400 gigs worth of BNG on it, because the application has bottlenecks too, but the actual packet processing horsepower in this server is about 400 gig. And that will move in our next generation Ice Lake platform, which is coming in Q1, Q2 next year. That will double. So we're putting more innovation into the PCI architecture, more innovation around the cores, the instruction count. So we'll get a greater performance return from that. The other piece of technology that underpins all of these workloads is the DPDK, the Data Plane Development Kit. So that's an open source framework. It's known throughout the industry now. It's basically the basis on which you build your packet forwarding applications, and it's free. It's in the open source community. We upgrade that with each processor generation, and it's freely available for you to start developing applications. The other thing that does bear mention is our NICs, our network interface cards, and there are slight changes in these. So standard NICs, data center NICs, they process standard data center protocols. But there is the realization that, the NIC is kind of the brains that sends the packets to the CPU. So we've got many cores, 24, 28 cores on a CPU, and you've got to direct the packets to those cores. So we have a technology called the Device Data Plane Personalization, DDP, and that's the piece of technology that recognizes, for instance, a BNG packet coming from the access network, and it will get it to the correct core with the correct virtual machine or container on it to process it. The same technology is applied for the applications that Mike has already mentioned. For instance, the access gateway function that would have to be capable of obviously passing both BNG or wireline access protocols from the access side and converting them to mobile or GTP type packets on the core side. So in that type of application, something like the AGF, you would have to have NICs that understand both wireline and wireless protocols, and that's what we use DDP for, to give it that profile that recognizes the requisite telecommunication stack. And that's the architecture and the base foundational ingredients that Benu have used. And Mike gave you a brief overview there. They've got the BNG, the user plane in software. They've got their fixed mobile converged adaptive gateway function. They've got their products, their Wi-Fi access gateways, which they've had in the market for years, and they're developing these new services around mobility and around the enterprise and residential services that Mike touched on earlier. So all of those functions are available today with Benu. They're built on our standard server, which is optimized for forwarding plane. And just the last thing I will mention is that we also have the fabric. We acquired a company called Barefoot 2 years ago, and we're also innovating around their technology, which today is very, very useful and very applicable to leaf spine switch technology that you need here for the OLT and access port aggregation. But also we're doing some innovation around that to make it more intelligent with respect to some of these applications and some of the traffic steering that will be required. So I'm going to hand back to Mike now. Mike's going to give you just an overview of the BNG and the performance and feature set that Benu are getting through adopting these technologies. So back to you, Mike.
Thanks, Paul. To Paul's point, Intel's done a fabulous job at really increasing the performance on their chipsets and using some of these new technologies and like DDP to improve the performance as well. So this chart is showing for each of the last 5 years, the million packets per second per core that can be processed on Intel-based processor. So this is per core. So an individual Intel CPU, may have 20 or more cores in it, and each core can do, at this point, close to 1 million packets per second. And this is testing that's done with a full system with both control plane and data plane. It's not just packet forwarding. In this case, these tests are done in a true BNG configuration where you've got the right, the subscriber tunnels coming in, and you're doing subscriber management and various policies. And what you see in this chart is over the years, almost a doubling of the performance per core. But then even further improvement, if you were to look at the performance to price ratio, it's definitely even higher than that, 2.6x higher, because you can now get more cores in a CPU for the same price. So you've got this huge increase in performance per core. You're getting more cores for the same dollar that you spend on a server. And so now, you can get around 6.5 gigabits per second per core with iMix, in a mix of different packet sizes. And that translates into, over 200 gigabits per second per server. And we expect a fairly significant, at least a 30% increase next year. So it's continuing to accelerate and improve in performance. And as a result, this is what is enabling this market, because bandwidth scaling is a key aspect of this market. And so, as you can see, with these kind of improvements, it really becomes a viable to have a software-based BNG in your network. So the Benu and Intel BNG solution is designed to kind of meet all those major trends and new requirements that are coming out on the market. So the first big one that we mentioned was the wired and wireless convergence and the evolution of the BNG to a 5G access gateway function. There's also something called an FMIF, which is more of an inner working function if you have a legacy BNG you want to continue to use. And then the UPF, the user plane function, is oftentimes integrated into the AGF. And so we support all of those. The other aspect, or the second key big trend, was not only supporting the scalability, but also the software-defined LAN and network slicing to address this proliferation of users and devices and applications. You don't want every user and device or application to have the same QoS, to have same bandwidth priority, to have the same security inspection. You want those to be tailored to the type of user, type of device. And the third aspect is enterprise class capabilities on traditional broadband home networks, such that the enterprise can really have a fully enabled work from home employee with the right prioritization, security, and analytics. And then the last thing is being able to have a modern, flexible, cost-effective solution for edge deployments. So pushing the BNG user plane in particular out to the edge, such that you can have edge services located closer to the user, like content distribution networks or low latency compute. And this last one is really critical for carriers, particularly as they try to differentiate themselves from some of the very large cloud providers who are really, trying to capture more and more of the computing market. And so the operators in the carriers have a strategic advantage that they have this very large infrastructure footprint of central offices where they can enable edge services. So how does this look like? At a very simplistic diagram in a network. So you could run you could take advantage of the disaggregated technology we're providing, as well as the CUPS architecture, which separates the control plane and the data plane. And here you see control plane running more centralized with different types of data planes. You could have hardware-based data planes aggregating some access connections, and you could have a more software-based data plane aggregating other types of connections. A lot of this work is being defined, again, by Broadband Forum, Also, the Telecom Infrastructure Project, or TIP, has been doing a lot of interesting things, ONF as well. And so we're all, both Intel and Benu, heavily involved in both of these, or all three of these standards bodies and initiatives. Now, the other thing that I want to highlight, of course, is with the software data plane, you can layer on services. And that was one of the key things that really stood out in the slide when I walked through the trade-offs. And so what that can look like is, on the left-hand side here, I'm showing a software data plane, which is using service function chaining to stitch in some third-party unified threat management platform, whether it be a Fortinet, Palo Alto, or Cisco platform. That is very straightforward to do when you have a software-based data plane and you have full control over determining, kind of based on looking deep into the packets, which of these are in need of going to that unified threat management platform. Because you're not going to want to send all traffic to those. It's going to be for perhaps the Teleworkers traffic, or maybe even a portion of the Teleworkers traffic, or maybe certain applications or devices. So you want to have that data plane intelligence, which usually comes with a software-based data plane. On the right-hand side, I'm showing a whole layering of different services, some of which are more appealing to the consumer, like parental controls, others that are going to be more for the enterprise. And you can layer on all these different types of services. So it could be, guest Wi-Fi types of services, various analytics, either at the device level or application level, security, could be web security and content filtering, or it could be denial of service protection or intrusion detection. And then there's a variety of network functions that could be run here. So you could run your SD-WAN out of this platform. You could have, again, like I mentioned before, CDN access. All of these things can be managed by the Benu Cloud. So we have specific solutions for some of these that can be managed from a cloud service, such that you don't have to go through a huge investment to build this out. You can just take advantage of the UIs, the user interfaces, and web applications that we've already built. So that really turns your BNG into a service-enabled BNG, and this is what will drive a lot of course, additional revenue. So Benu is significantly differentiated along two different axes that you might consider when you're looking at a BNG. So one is the architecture flexibility and performance. So there's different levels of kind of, I'd say, architecture advancement, and ranging from using Intel DBTK as sort of a starting point and doing a virtualized solution, to moving to a cloud-native approach, providing a hardware, hybrid software and switch hardware solution. And then the other axis is not about architecture, it's really about the value-added capabilities. And most of the BNG vendors really sort of focus on just the core components there of virtualized solution using DPDK. They'll do some CGNAT and DPI, deep packet inspection. And some additional vendors go beyond that, support Wi-Fi access gateway, and they have a roadmap to AGF. Some of them are starting to implement cups, but Benu is really much further along on all of these aspects in terms of moving to cloud native architecture, supporting switch offload, and then of course the services. We have a whole line of business that is focused on this. We have carriers rolling out various business and consumer services across their networks using our software. So the thing I want to leave you with is, what kind of BNG is right for you? And I'm not saying, one is the right one and the other one's the wrong one. I mean, if you're really focused on cost, you might take a different approach, like we saw on the trade-offs. If you're more focused on how do you differentiate yourself, and drive new revenue streams, you'll take probably a more software-based approach. And if you look at the car market, Tesla is really an example of a car that has far more software than any other car in the past and is far more end-user aware. And as a result, they are really disrupting the market. This is just one example of a market that's being disrupted by software, but there's actually many examples. For example, if you think back to a cell phone that you may have had, 15 years ago, it really didn't evolve much over the period of time that you owned it. But then the iPhone came out. And you buy an iPhone, and 5 years later, you're doing totally different things with that iPhone. Even if it's the same iPhone, you're doing totally different things with it. It really evolves. It's far more future-proof. Although it costs more, right? So there's a trade-off there. And then another area or industry that's being completely disrupted by software is music, right? You had the old radio and radio stations, and then you have a service like Spotify, where it's continuously evolving, and continuously adding new features. Has nothing to do almost nothing to do with the hardware that you're using, and it provides completely tailored services to what you like, what your preferences are. And these are the types of technologies that are really disrupting the market. And so this is something to think about, as you make these big decisions on where you want to take your BNG. Are you focused on more, just the cost and let's just get some pipes out there? Or are you thinking a little more broadly about how other industries are taking advantage of software? So with that, I'm going to, I think, open it up to questions.
Sounds great. Thanks so much, Mike and Paul, for that great presentation. We do have a few questions that have come in. So the first one is directed at both companies. How are you working within the 5G space, and what are your estimates for FMC deployment timeline? Mike, why don't you take that first?
Sure, yeah. So we are starting to build some proof of concepts with other partners around the 5G access gateway function, which is, like I mentioned before, an evolution of the BNG. The timeline for actual deployments, probably more lab trials and POCs mostly next year, at least is my view. It'd be interesting to hear what Paul says. And then maybe, and then actual commercial deployments the following year.
Yeah, see similar timeline. We work with some of the operators just on platform definition, what augmentation would be required to do fixed mobile convergent, but we see a very similar path to production, RFIs next year, probably end of next year, proof of concept trial, and then some deployments in 22. Very similar, yeah.
Great, thank you. The next question is directed at Benu. So Mike, are the services deployed in production today?
Yes, we have, I'll just use one customer as an example. So Liberty Group has deployed us in the Latin American territory for specifically for their Teleworker service. And so they're rolling that out across, 20 odd countries. And it's one of their key initiatives for them. We also have other deployments that are more business site focused, where the services are layered on for individual business sites. Could be a mix of guest Wi-Fi, broadband fallback to a second connection, static IP, and also some additional security services like web security and content filtering. So we do have some commercial deployments, a variety of commercial deployments of the services.
Great, thank you. And I'd love to get both of your thoughts on this next one. What are some design considerations ISPs should be thinking of when we're looking to upgrade our BNG BRES?
You want me to go first this time, Bree?
Sure, go for it.
Yeah, so I think we've touched on a lot of them. Mike presented a very good slide there on the on the axis. If you're just looking at cost and a one-for-one replacement, it's probably perfectly fine to go with the legacy type solutions, but that's not what we're seeing in the market more and more. We touched on it. Operators have this huge bandwidth capability at the edge of the network. They want to put down a platform that allows the legacy function plus new services that are easily deployed. And then there's that whole cloud native thing. Can you do continuous integration, continuous development on a legacy telco platform? So all of those considerations and disruptive technologies lead into the type of solution that you've seen today. So yeah, lots to consider.
Yeah, I'll just add on. I think some of the carriers are starting to look at different types of BNGs, or particularly on the user plane side. So having some BNG user planes pushed right out to the edge for low latency services or for access to content distribution networks further at the edge, versus having other BNGs user planes for other types of use cases that would be more centrally located. So for just general internet browsing or things like that. And so we see some of the carriers starting to look at using different types of user planes. And I think, from a cost perspective right now, there's not a whole lot of difference. In terms of the different architectures, like I mentioned, there's like a 20-cent advantage there, I think, for the hybrid solutions, but they're not, of course, yet to market yet. So if you need to do something now, you're really sort of stuck with either sticking with your legacy approach or taking a more software-based approach right now.
Great, thank you both. I think we have time for one more quick question. If I need to implement 3GPP function into our core, what's the best option to go for from Benu?
Yeah, so I think if you are implementing the 3GPP functions, it's really going to be the access gateway function that's going to enable your fixed mobile convergence architecture. And so, and usually that AGF would include the user plane function, so that you're just touching the packets once. You can run them separately, but those two components we would expect typically be integrated into one platform. And so, but we give operators the option to do both.
Excellent. Thank you so much. Thank you both for the great presentation. Thank you to our audience members for the great questions. Please don't forget to give us a rating for the live recording so that we can continuously improve the quality of our webinars. And be sure to join us next time, Tuesday, December 15th at 8 a.m. Pacific, for Edge is the New Cloud. Enterprises can now launch 5G Edge services in minutes, featuring Aleph Edge. Thank you again for joining us today. This concludes our webcast.